Okay, this is a short revision video on all the stuff in Mathematics Core 1. It's designed for anyone doing Edexcel AS level maths. It's going to be a fun ride. Okay, the first thing we're going to look at is indices and surds. I think this is called algebra and functions in your textbooks, but I prefer to call it indices and surds because that's what's in it. Indices is when you've got something to the power of something else. So for example, a to the m is a times a times a times a, and there'll be m a's altogether. So for example, if m was 3, you'd have 3a, so a times a times a. So say that a was 2, you'd have 2 to the 3 is 2 times 2 times 2, which is 2 times 2 is 4 times 2, which is 8. Say you're asked to multiply a to the m by a to the n, you've got a times a times a m times, and then times a times a times a n times. So you've got a times a times a times a, however many m times, then a times a times a, how many n times. So you can essentially do a, the m plus n. It's easiest to explain this with an example. So say that m was 3 and m was 2, you'd have a times a times a times a times a, which is a times a times a times a times a, which is 5a's, which is 3 plus 2. Hence we've proven that a plus m is a 3 plus 2. Well, at least for this example, it's not really proof, but you know what I mean. If we're doing a to the m divided by a to the n, we do a to the m minus n. And again, it's so much easier to explain this with an example. So m is again 3, n is 2. A to the 3 over a to the 2. A times a times a over a times a. And we know we can cancel down, so we'll get rid of the 2a's in the bottom and 2a's in the top. So we'll just have a left, which is the same as a to the 1, and a to the 3 minus 2 is equal to a to the 1. These rules are really important. A to the m to the power of n is the same as a to the m times a to the m times a to the m however many times. So it'll be n many times. So this is the same as a to the m times n. Again, example is the easiest way to show this. So a to the 3 to the 2 is the same as a to the 3 times 2, because a to the 3 is a times a times a. And if we're going to square all of that, we'll times it by that again. So a times a times a times a times a times a, which is the same as a times a times a times a times a times a, which is a to the 6. And a to the 6 is the same as a to the 3 times 2. And it works for much bigger powers as well, but it's going to take a lot of room if we did bigger powers. And there'd probably be too many a's. I think a's look really weird. The longer you look at them, the weirder they look. They look like a backwards 6, sort of, but I don't think you really care. When you see a negative with indices, you do the reciprocals. You do 1 over, and then whatever you've got, and you take away the negative sign. So if it's a to the minus m, you'll do 1 over a to the m. And that's just generally what you have to do. I'm not quite sure why. I'm sure there's a way of explaining it, but I'm not clever enough to know. So for example, a to the negative 2 is the same as 1 over a to the 2. So say a was 3, 3 to the negative 2 is the same as 1 over 3 to the 2, which is 1 over 9. This one comes up quite a lot, so it's pretty important to know this. When you get indices that are fractions, it starts to get interesting. If you see a fraction, this means some rooting. Square rooting, cube rooting, whatever rooting to whatever power. It's really exciting. So if you've got a to the n over m, you'll do a to the n, and then you'll root it to the m. One really stupid way of remembering this is, because you know the n's on the top, so it's the most important because it's on the top, so it has to go under the roof so it doesn't get wet because it's important, and then m's in the bottom, not so important, so it has to go outside and it gets wet. If anyone wants to know how to remember it, that's how I remember it. Let's do a quick example. A to the 1 over 2, the 1's the most important, so the 1 goes on the inside, so it's a to the 1, and then in this case we're just square rooting it, and that's the same as square root of a. I think the hardest ones of these are when they combine the fractions with the negative. I spent my school life hating those so much. GCSEs, ugh, I don't know why I said school life, I'm still at school. This slide is pretty empty, but very important nonetheless. Anything to the 0 is always 1, except for 0 to 0, which you can't do, calculator error. Well, you didn't get a calculator in core 1, haha. So anyway, anything to the 0 is always 1, 4 to the 0 is 1, 3 to the 0 is 1, pi root 3 to the 0 is 1. Basically, anything to the 0 is always 1, and if there's a mark for this, you want it. It's a really easy mark to get, so just make sure you know this. Surd time. Again, I had a long time this battle with surds. I couldn't do them. I spent the lesson, we learnt about them making absurd jokes, and I thought it was hilarious, but unfortunately I missed everything that was being said, so I had quite a bit of trouble with them for a long time. There's a few really basic surd rules, like root AB is the same as root A times root B. If you don't believe me, try it on a calculator. For example, root 4 times 25 is the same as root 4 times root 25, and root 4 is plus or minus 2, and root 25 is plus or minus 5, so root 100 is plus or minus 10. You've always got to remember that it's plus or minus, because they'll expect you to put both solutions and you'll lose a mark if you don't put them both, and you could lose quite a lot of marks. Like I was doing a paper earlier, forgot there was 2 solutions and lost about 3 marks or something because I got quite deep into the question, so I lost loads of marks there, really upsetting, so make sure you don't do that. Moving on to division with surds. Now root a over b is the same as root a over root b. And again, examples are the best way to show this. So say a was 16 and b was 4. We could do root 16 over root 4, which gives us plus or minus 4 over plus or minus 2, which means our final answer is plus or minus 2, and we can prove this is true, because if we square plus 2 or minus 2, we'll get 4. And if we square root 16 over 4, we get 16 over 4, which is also 4. You've just got to remember to get those negative values in. Just so important, because you don't get a calculator anyway, but the calculator only gives you positive values. And it's just so important to get the negative ones. And I'm stressing this because when I made this PowerPoint last night, totally forgot about the negative values. I didn't wake up in the middle of the night. I was doing some Einstein puzzle thing. It was really fun. It was the zebra puzzle. I stayed up till 2 o'clock doing that. And then it suddenly hit me that I needed to put the negative things in this because I'd forgotten them. So very important. And for those of you worrying, I don't usually spend my night doing puzzles. I just saw it on Twitter and I just had to have a go, and I couldn't go to sleep until I did it. So that's why I was up quite late. Rationalising surds. This is a really important thing. It's pretty much always one of the questions. It'll usually be a bit harder than this. It'll be what we see on the next slide. But this is really basic rationalising. So 1 over root a, because you can, as long as you do the same to both top and bottom, that's not change the fraction at all. So say we multiply top and bottom by root a, we'll get root a over a. And rationalising basically means we'll get rid of the surds on the bottom. So all the surds will have to be on the top. So when you've got a single surd on the bottom, just multiply it by the same surd and you'll get rid of the bottom surd. And you've got to obviously times top and bottom by that surd, so you'll get the surd on the top multiplied by whatever was there before. So for example, 1 over root 4, we don't want root 4 on the bottom, so we'll times top and bottom by root 4, and we'll get root 4 over root 4 times root 4, which is the same as root 4 over 4, which is root 4 over 4 is plus or minus 2. So we'll get plus or minus 1 over 2, which is plus or minus a half, and if we go back, we can see that 1 over root 4, obviously 1 over plus or minus 2. So they're equal. Now this is the kind of thing you're going to get in your Core 1 exam. So you'll get z over a plus root b, and you'll be told to rationalise it. So when you rationalise something that's over a plus root b, you always do a minus root b, because then you'll get one of those things. I can't remember what it's called, but it's like when you're solving a quadratic and you've got x plus a and x minus a as your two things. So they sort of cancel each other out almost, so you'll be left with x squared and then minus a squared. But obviously, let's go back to this example here. So we've got a plus root b, a minus root b. We'll get a squared plus a root b minus a root b, so those two cancel each other out, minus root b squared, which is the same as minus b. So that's what we'll get on the bottom, and then on the top we'll just have z, and then times a minus b, root b even. Hope you followed that. If you didn't, just pause now, stare at the screen, and make sure you remember that, because that is the most important thing. Because so many people lose marks over it, and it's just, that's the easy marks. And back in the day when I didn't get surds, I lost so many marks over this. I look back, it's so stupid, because it's so easy once it clicks for you. Just make it click, make it happen. Let's do a quick example. So say we've got 5 over 3 plus root 4. We want to get rid of the 3 plus root 4, so we have to multiply it by 3 minus root 4. So on the bottom we'll have 3 squared, which is 9, plus 3 root 4 minus 3 root 4, so they cancel each other out, and then minus root 4 squared, which is 3 squared minus plus or minus 2. So obviously I'm not going to write it all out because there'd be a few different answers you could get. And then on the top we will have 5 times 3, which is 15, minus 5 times root 4. Obviously you could keep going with that as well and get, plus or minus 2, that sort of thing. But you leave it like that. They won't usually give you something where you can have lots of different answers. I've never seen that. They tend to give you things like root 37, which you can't root. They'll give you something like that, so you just leave it. Don't ever try to work it out yourself, because if they've not given you a calculator, they don't want you to work out root 37 or something like that. There is an exception though. Say they give you a surd and you look at it and you think, oh, I bet I can make that more simple, then make it more simple. For example, root 63. You've got 63, and 63 you can split, because 63 is 9 times 7. So you'd do root 9 times root 7, and then root 9 is 3. So you'd have 3 or plus or minus 3 times root 7. If you've made it this far, I'd like to congratulate you, because personally that indices and surds stuff put me to sleep. It's the most boring stuff, it's just really important, sadly. But we're moving on to quadratic equations, which is much more exciting, if that's the kind of thing you're sad enough to get excited about. Quadratic equations always take the form ax squared plus bx plus c, and there's always got to be an actual number, it can't be 0. If a is positive, the graph will be a happy face, because positive is happy, so it'll look like a smiley face. If you draw it on the axes, that's the shape it'll look. And if a is less than 0, it's a negative number. Negative people aren't smiling, they're sad, they've got a sad face, so it'll be that shape. There are 3 ways to solve a quadratic equation. There's the quadratic formula, completing the square, and factorising. You'll usually try factorising first, and then you'll try one of the others, because factorising is the easiest. But for some reason, we're going to do that last now. Not sure why I did that. This is the quadratic formula, and it's pretty rare that you'll have to use this in Core 1, because they don't give you a calculator. And unless it's really easy numbers, you don't have to be square rooting without a calculator and stuff. But it's really important for you to learn, because they don't give it to you in the formula booklet. You don't want to walk in thinking, good, they're totally going to give me the quadratic formula, and you get there and it isn't there. So just make sure you've checked through the formula booklet and you know what's going to be in it. I think I can check now if you want, one sec. Okay, for Core 1 you get the surface area of a sphere and the area of a curved surface of a cone. I've got no idea why, because they're not on the course at all, but you get those in case you really wanted them. But you do get arithmetic series, and that stuff will come on to you later, and I'll tell you which ones you get. But you do get those, but that's it for Core 1. You don't get a lot. Sad times. I mean, if you look further on in the book and you look at all the stats stuff, it just makes you feel ill, so quite frankly you don't want too much, because there's so many statistics tables, they're just, there's pages and pages and pages of them, and they're just horrible. Horrible, horrible, horrible. Moving on now to completing the square. I used to hate completing the square, but now I find it quite fun. Completing the square, you'll have x squared plus bx plus c, and you'll put x plus half of b in brackets and you'll square it. And you'll take away the b over 2 squared, because you don't want that, and you'll add c. I'll just go through that, explain why. X plus b over 2 squared will give you x plus b over 2 times x plus b over 2, which will give you x squared plus b over 2x plus b over 2x, which is bx, plus b over 2 squared. And then if you take away the b over 2 squared, you'll have your x squared plus your bx, and then you'll add c. So then what you'll do is you'll take your b over 2 squared and your negatives, well, it'll become negative, your c over to the other side, and you'll have x plus b over 2 equals the square root of b over 2 squared minus c. So x will equal square root of b over 2 squared minus c minus b over 2. I think there's an example on the next slide, because that makes your head hurt just looking at it. Okay, do a nice easy example. X squared plus 4x minus 12 equals 0. You have your x plus half of b, which is 4, so x plus 4 over 2 squared minus 4 over 2 squared minus 12 equals 0. So x plus 2 squared equals, you'll take your 2 squared over, your 4 over 2 is 2, so 2 squared over and your 12 over. So you'll have x plus 2 squared equals 2 squared plus 12. Then you'll square root both sides. X plus 2 equals square root of 16. So x equals 16 minus 2, or square root of 16 minus 2 even. Square root of 16 is plus or minus 4, and then you'll take away 2. So your final answer is either going to be plus 4 minus 2, which is 2, or minus 4 minus 2, which is minus 6. When you've got a coefficient of x squared which is greater than 1, so for example in this case it's 2, you just divide the whole equation, both sides, by 2, because the other side's 0, so it doesn't affect the other side. So 2x squared divided by 2 is x squared, 8x divided by 2 is 4x, and minus 24 divided by 2 is minus 12. Make sure you divide every single term by 2, or whatever your coefficient is, because I always forget to do the last term for some reason, Bit stupid, but make sure you don't do that. Then the rest of this just carries on like it did last time. I mean, it's different numbers, well, it's the same numbers now, we've divided by 2, but it was different numbers at the start, and just carries on, and you'll do it all the same as you did last time, so we won't run through that again. Factorising time. Factorising is one of the most satisfying things. I mean, you'll try, and as soon as it factorises, it'll be the most beautiful thing. So, example of factorising is x squared minus 2x minus 15 equals 0. So you're going to look for two numbers that multiply to make the c, and that add to make the b. So for this, we've got our minus 15, so numbers that to multiply to make minus 15 are 3 and 5, one of them will be negative, and 15 and 1 will be negative. Obviously 15 and 1 are quite far apart if we want to get 2, so we'll go for 5 and 3. Now 5 and 3, it'll be the positive or negative 3, positive negative 5, but we want to get negative 2 altogether, so it's going to be 3 and then negative 5, because 3 minus 5 is minus 2. So x plus 3 will be in one bracket, and x minus 5 will be in the other bracket, and that'll equal 0. So we know that one of those two brackets must equal 0, so we know that x must equal either negative 3 or 5. Now we're going to go for something a bit more difficult, which is when we've got a coefficient of x squared that is greater than 1. So to start with this, we'll find two numbers that multiply to make AC and add to make B. And there's an example on the next slide, so that's the easiest way, I think, to show you how to do it. Okay, so our example is 6x squared plus 5x plus 1 equals 0. So, I mean, you always got to get it into that form first. Sometimes they give you like 6x squared plus 5x equals minus 1. So just make sure you've got 0 on one side and all the others on the other side. So the two numbers that multiply to make AC is 6, so it's either going to be 6 and 1 or 2 and 3. And they've got to add to make B, obviously 6 and 1. Oh my god, they could. Because you could do 6 and then negative 1. But you don't want that, because then one would have to be negative and one would have to be positive, and you need a positive one at the end. So our two numbers are going to be 3 and 2, because 3 times 2 is 6, and 3 plus 2 is 5. And then you're going to split your quadratic equation. Some people do this differently. I do it in a grid. Well, actually, I usually just do trial and error, because I'm lazy like that. But most people split it. I think the grid method is the easiest method here. So you'll have your 6x squared and your 1 will go in the opposite corners, like you can see. And then we've worked out it's 3 and 2. So one of them you'll put 3x and one you'll put 2x. It doesn't matter which way around you do it. Then what you'll do is you'll take out the highest factor along each row in each column. So along the first row, the highest factor is 3x. And then 3x times what equals 6x squared. And you'll see, oh, 3x times 2x is 6x squared. So 2x will go on the top there. And then hopefully it'll all fall into place and you'll get 3x plus 1 and 2x plus 1 in two brackets. I'm just going to leave this on the screen. Like, just pause the thing now and look at it. And then hopefully it'll sink in, because I can't explain it. It's just what happens. And then you'll get your two brackets, and then they equal 0, and then you could work out here x is negative a third and x is negative a half. I think I missed out saying this earlier. It's quite important. Make sure that you've got a value of x for which each bracket equals 0. So 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1 over 3. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1 over 2. That sort of thing, but for whatever brackets you've got, whatever question you've got. When you've got a quadratic equation that takes the form ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. And remember earlier I talked about that trick to know if a equation will factorise. If b squared minus 4ac comes to make a square number, then your equation factorises. Otherwise, I'm afraid to say it probably doesn't. The discriminant is also really useful for telling you how many roots an equation has. Roots are when the line you draw, because obviously ax squared plus bx plus c, if it equals y, then you'll get a line, like a curve, a quadratic function or whatever you call it. But b squared minus 4ac will tell you how many times your curve touches or crosses the x-axis. If b squared is greater than 4ac, you'll have two distinct roots, which means that your curve hits the x-axis at two separate points, means it crosses it twice. If b squared is equal to 4ac, it means there's two equal roots. So essentially there's one root, which means that your curve hits the x-axis once, which means it can't cross it, so it just touches it So if b squared equals 4ac, the bottom of your curve, the happy face, or I suppose the sad face, it will touch the x-axis just once. If b squared is less than 4ac, there's no real roots, which means that either the base of the happy face is above the x-axis or the top of a sad face is below the x-axis. So your curve never actually comes into contact with the x-axis at all. Moving on now to a whole new world of fun, that is equations and inequalities. Inequalities is when you've got a more than or less than or more than or equal to or less than or equal to sign within your, let's call it an equation. So you'll have that sign somewhere and it's called an inequality. And it can essentially be treated a bit like an equation. So say we had 4x is greater than 2, we can just divide both sides by 4 and we'll get x is greater than half. And so you basically treat it the same as you'd treat an equation. So say you had an equation 4x equals 2, you just divide both sides by 4, so it's exactly the same. There is one really important rule you need to know, that is when an inequality is multiplied by a negative number, the inequality sign turns around. I mean, I don't think I've ever had to multiply anything by a negative number, but it's just important to know. So just showing why this is down here. So we've got 4 is greater than 3, and we decided for some reason to multiply both sides by -1. Obviously negative 4 isn't greater than negative 3, so we have to flip the sign around. So just remember, whenever you multiply an inequality by a negative number, just flip that sign around. Something you might have to do that there isn't a slide on this about is you might have to combine inequalities. So you might get x is greater than 4 and 3 is less than x, which is less than 5, and you have to combine them, so you have to say that x is between 3 and 4. That's really basic stuff, so hopefully you're alright with that. And if you find it hard to visualise it, then just draw a number line and draw your lines with the circles filled in or not on each end, and then that will hopefully help you see where the overlapping section is. And it's just the bit where there's both lines, so where the value of x is true for both of the inequalities. That's the bit that you need to take. Probably should have made a slide on that, but if anyone has got no idea what I'm on about, then just comment below and tell me, and I'll try to explain it a bit better than I have done here. To solve a quadratic inequality, so say you had x squared plus 4x minus 3 is greater than 0. You just treat it like a quadratic equation, and then you'll factorise it and find your roots, and you'll be able to draw it out so you'll know where it crosses the x-axis. And then say if it says it's greater than 0, it's the green bits, and if it says it's less than 0, it's the red bits. Take into account whether it's greater than or equal to sign, or whatever it wants. And then you'll just literally write it out. So you'll have two inequalities if it's above 0, if it's greater than 0, and one inequality which will have an x value in the centre of it if it's for less than 0, at least if it's that shape. And if it's the other shape, if it's a sad face, then you'll have the opposite way around. So hopefully that's okay. I probably should have done an example again, but for some reason I was probably half asleep when I was making this PowerPoint, so that's probably why there isn't one. Sketching curves. I say curves, but we're actually going to look at a line first, and hopefully you recognise the equation at the top there. Obviously it's the equation of a line, y equals mx plus c. M is the gradient, c is where it crosses the y-axis, and c occurs when x equals 0. And it meets the x-axis when y is 0, because obviously if you just picture in your head when y is 0, that's the point where it's crossing the x-axis, because it's got no height, so it must be either touching or crossing the x-axis. To find the gradient, which is m, you do rise over run. I'm going to stop this now and put a diagram in for you. So I literally just did that triangle really quickly for you, and you can see we've been given 2 points. If you can't read it, it's 1, -2 and 4, 8. And to find the gradient of between those 2 points, I find it really easy to draw a triangle. So I'll draw a triangle. I know that the width between them is 3, because 4 minus 1 is 3. And I know that the height between them is 8 minus 2, which is 10. And we know that gradient is rise over run, so the gradient of that bit of line is 10 over 3. Which you'd then use. You may be asked to differentiate to get the gradient as well, but we'll come on to that later. That's really exciting. So once you've got your gradient, and they'll have given you a point as well, hopefully, you'll sub in the x and y coordinates of that point, x and y, and you'll sub in the m that you've got, the gradient you've got, and then you will just rearrange your equation to find out what c is, and then you'll rewrite it in whatever form they ask for. So they might ask for y equals mx plus c, or they might ask for ax squared plus bx plus, no, shut up, plus by plus c equals 0, which means they basically want you to rearrange it and have it so that all of your a, b and c are integers, so no halves or fifths or anything. Only whole numbers, please. Now, quadratic curves are much more fun to sketch. They meet the x-axis when y is 0, and they'll meet it twice, so you have to solve the equation you'll get to find the roots, which is the roots are when it touches the x-axis, and it will meet the y-axis when x is 0, so you'll sub in x equals 0 and find out when it meets the y-axis. And when x is 0, y is c, so it's basically whatever your c value is. If you've completed the square, make sure you're really careful to sub in your x as 0, and then, because you'll have like x plus 1 squared minus 3 over 4 or something, so make sure you put your x in as 0, and then you have your 1 squared minus 3 over 4, which is obviously a quarter. So just make sure you don't make any assumptions. Time for the reciprocal function, which is also known as a rectangular hyperbola because its asymptotes are at right angles to each other. They're perpendicular. Check that out. FP1 knowledge, yeah? So a reciprocal function takes the form of y equals k over x, where k is a integer, it's real and it stays the same. Well, I assume it's real, we're doing core 1 here. So k doesn't change. It's constant, that's the word. So when k is greater than 0, your graph will take the form on the left, and when k is less than 0, your graph will take the form on the right. I'm trying to think of a way to help you remember this, but I think I just remembered it by learning it in the end. It took me forever. This one really confused me doing these. GCSE. This was GCSE, I just couldn't do them, couldn't get my head around them. The asymptotes of reciprocal functions are found at y equals 0 and x equals 0 when the graphs haven't been shifted or stretched or changed or anything. In fact, if they've been stretched, the asymptotes stay the same, unless they've been shifted as well. So it's just shifts that make the asymptotes change. This is a really good time to move on to graph transformations, which at core 1 consist of stretches and shifts. In fact, I think it's the same all the way through. Well, I've done up to core 3 and I've never come across anything else, but I still use them in core 3 all the time. They get harder though, it's horrible. Graph transformations. So you'll typically be given the normal graph, as we're going to call it, which is y equals f of x. Now there are two types of things you'll have to do. There are shifts and stretches. Shifts are when you're adding something, and stretching you'll be multiplying by something. Now, it's going to sound so stupid, but the way I remember it is if it's inside the brackets, you're in a lift, but the lift is broken, so you don't go up and down, you go side to side, and it's really sad, but that's actually how I remember it. I failed at this all through GCSE until I came across this lift idea in my head. It suddenly sparked. So just remember, if it's inside the lift, which I should have explained, the lift is the brackets. If it's inside the brackets, if it's inside the lift, you shift it left or right, and if it's outside the lift, it can actually go up and down because it's in the stairs, and the stairs allow it to go up and down because they're not broken, because stairs can't break unless there's a fire or something terrible. So anyway, sorry, back we go. If it is a vertical shift, so it's outside the brackets, you literally do what you'd expect. If it's positive, you move the graph up by that much. If it's negative, you move the graph down by that much. But times change when we come to horizontal. Horizontal is always really awkward, as you'll see for stretching as well. Horizontal, it'll be inside the bracket. Now, f of x, I can't tell if that's plus or minus, can't even read my own stuff there. But if it says plus a, you don't move it to the right as you might expect, you move it to the left. So positive goes left and negative goes right. So if it's f of x plus a, you will move the graph to the left, and if it's f of x minus a, and all in the brackets, you will move the graph to the right by a. Moving on to stretching. Again, if we're stretching up and down, we are outside the lift, and if we are stretching left and right, we are inside the lift. We stretch up and down by a scale factor of a, so we've got y equals a of f of x. We will stretch up and down by a. So say we have 2, 4, the point 2, 4. Now the x point 2 doesn't change, or the x coordinate 2, I don't know what you call it, but that part doesn't change because we're not moving left or right, we're moving up or down. So 2 stays the same, but I can't remember what we had now, I think it was 2, 4. But 4 will stretch by a, so say a is 3, 4 will stretch by 3, it will multiply by 3, so our new point will be 2, 12. Points below the x-axis will stretch downwards, so say we had the point -3 and a was 4, the point, well, y coordinate -3, the point would turn to -12, so x -12. Now the last one on this table, oh, I just knocked my phone against my chair. The last one on this table is kind of confusing. This time we're in the lift again. Now this is going to sound so stupid, you're probably fed up with my stupid ways of remembering things, but has anyone seen Charlie and the Chocolate Factory, or read Charlie and the Chocolate Factory? Remember when that last boy that really liked TV, I've got his name, it might be Mike or something, let's call him Mike. Remember when Mike went through the TV and he shrunk? Now, the way I remember this is we pretend the lift is a TV and Mike is A, and he's gone in the TV and he's shrunk. So we stretch our graph, obviously we're stretching it left and right because we're in the lift, and we're stretching it by a scale factor of 1 over a, so we've shrunk it down. So it'll usually come towards the y-axis unless you're stretching it by a half or something stupid. So yeah, say we had the point 2, 4, the y point stays the same, so it'll still be 4, but the 2 point, say a is 3, the 2 point will become 1 over 3 times 2, which is 2 over 3. So it'll be 2 over 3, 4, or whatever I said before. If anyone has made it this far, I really congratulate you, because I'm falling asleep and it is only 8 o'clock, which is a bit embarrassing. Is it 8 o'clock? Yeah, it's 8 o'clock. But hopefully the excitement and the thrill of coordinate geometry is going to wake me up. Okie-doo, coordinate geometry. Obviously we've seen this equation quite a lot. Y equals mx plus c, m's the gradient, c is the y-axis intercept. That means the point where it crosses the y-axis. I know I keep showing this to you, but it's just so important that you know it. It's just fabulous. I still use it today, and I'm doing like C3 and stuff. But I am also doing C1 as well, because I'm taking, obviously, all my AS exams at the end of this year, so of course I still use it. Okay, lines, gradients. Parallel lines have the same gradient. I mean, if you draw them out, you will see why. Perpendicular lines have the gradient m and the negative reciprocal of the original gradient, so -1 over m. It's quite exciting, important, interesting to note that if you multiply the gradients of 2 perpendicular lines, you will get -1. So that's a really good test for you. And this last bit we've done before, it's the line joining 2 points, is essentially rise over run, so y2 minus y1 over x2 minus x1. It's the one we did with the triangle earlier, if you can't remember. Okay, do the equation of a line. If you're given 2 points on a line, x1, y1, x2, y2, y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And there's no point doing an example of this really. I mean, as long as you sub it in, you will get the right answer, and you multiply it out and you'll get y equals mx plus c, but it takes just a different way of doing it. I prefer the method where you use those two to find the gradient, sub in 1 into y equals mx plus c, and then you'll find your c, and then you'll get your m and your c. That's what you need, because you can sort y equals mx plus c, but using your m and your c. But if that's not the method you want to use this method, then just learn the formula, and Bob's your uncle. Did I really just say that? Bob's your uncle? I've not got an uncle called Bob. I've got an uncle called Hugh, and an uncle called Nigel. Nigel's a cat's name. Sequences and series. Okay, the big difference between sequence and a series. A sequence is just a chain of numbers, so 1, 2, 3, 4, 5, 6, or 2, 4, 6, 8, 10, or 8, 12, 16, I don't know how you want to carry it on. And then a series is when you're adding together all of the numbers. So, for example, 1 plus 2 plus 3 plus 4 plus 5, 2 plus 4 plus 6 plus 8 plus 10, stuff like that. And that means you can have a sum of a series as well. And you get the special E symbol, and we'll come on to that later. Because we're doing arithmetic sequences, it means we're adding on the same thing each time or taking away the same thing each time. So the amount we're adding on or taking away is called the common difference, which is called D. So say the first term is A, the second term will be A plus D, and then we'll add another D to get the third term, so A plus D plus D, so that's A plus 2D, and so on and so forth, where UK plus 1 is UK plus N. So UK is the previous term plus the common difference. And the first term we always call it A, and we always call the common difference D. With sequences, often they'll tell you the first term, and then they'll get you to work out another few, because it's quite hard to do much with sequences, because you can't do sums or anything, because that's a series. A series obviously looks quite similar to a sequence, but it's got the pluses in the middle, so the first term is A, second term is A plus D, third term A plus 2D, and so we know the nth term is A plus n minus 1D, where n is the, say the 10th term, say the nth term is the 10th term, n is 10. So the nth term is A plus n minus 1D, and it's n minus 1 because the first term, A, has no D's added to it. So we have to take 1 away to account for that. There are two ways of calculating the sum of a series. So there's n over 2 times 2a plus n minus 1d, and n over 2 times a plus l, and from that we can gather that 2a plus n minus 1d is equal to a plus l, where a is the first term, l is the last term, d is common difference, and n is the number of terms. The most you'll really have to do with series questions in Core 1 is just plug numbers into formulae, and appreciate that there are two different ways of calculating the sum of a series, know which one to use, and appreciate that that stuff in the brackets there is equal. Again, if you start plugging your numbers into the formulae and it looks like too difficult a formula for you to be able to work out in your head or work out with very basic calculations on paper, then you might want to consider checking what you've done, because it's quite likely you might have gone wrong, because they never ask you to do something too complicated without a calculator. Moving on to differentiation now, and a quick shout out to Martin, who is, as of yet, unable to differentiate. That was so random, oh dear. Now, differentiation, use it to find the rate of change of something, or at least in Core 1 you'll just be finding out the gradient of a line. And the gradient to a curve at a point, because you'll be differentiating curves, well, equations of curves, is the same as the gradient of the tangent at that point. And the tangent is the straight line which touches your curve at a point but does not cross it. And to find the tangent gradient for your curve at a point, you will differentiate the equation, which I'll show you how to do in a second, and then sub in the given value of x at that point. So they'll tell you, find the gradient of the tangent at 4, 1, so you'll differentiate and then you'll sub in x equals 4 into your equation, and that will give you the gradient of the tangent. When it asks you to differentiate f of x, it will put either dy over dx or f flick x. And if you see two flicks, so f flick flick x, that means differentiate it twice, so differentiate it once and then differentiate your f flick x to get f flick x. So to differentiate something, you'll multiply your expression by the power and reduce the power by 1. So for example, 2x to the 3, you will multiply the whole expression by the original power, which is 3, so 2x to the 3 times 3 is 6x to the 3, and then you'll reduce this power by 1, so you'll get 6x to the 2. Let's try minus 4x to the minus 3. We can just hit a negative to the outside for now, so we know we've got one negative on the outside and one negative on the inside, so it should say really negative 3 times 4, but it doesn't matter because that's the same. So we've multiplied 4 by negative 3 to get negative 12. So we've got negative 12x to the negative 4, because we've done negative 3 and we've taken away 1 to get negative 4. And because we've got a negative on the outside of the bracket, as you can see at the bottom there, we've got plus 12x to the negative 4, because negative and negative is a plus. And then we've got 5x, and if you've got anything where there's just one x, you literally just take away the x. So 5x will go to 5, 4x will go to 4, 12x will go to 12. And then say that you've got a term that has no x's in it whatsoever, so 5, 3, 2, 1, you just get rid of it totally. So 5 goes to nothing. So say, for example, for the sake of just explaining it, say that negative 5 goes to 0, so plus or minus 0 doesn't make a difference, so you just ignore it in the end. So if we're differentiating your 2x to the 3 minus 4x to the minus 3 plus 5x minus 5, we know 2x to the 3 goes to 6x to the 2, negative 4x to negative 3 goes to plus 12x to negative 4, 5x we know it goes to 5 because just get rid of the x, and then the negative 5 we get rid of it altogether. The normal is perpendicular to the tangent, means it meets it at a right angle. So say you want to find the gradient of the normal, you find the gradient of the tangent, and then you find the gradient of the normal because you know that the gradient of a line that's perpendicular to another line is the negative reciprocal of the gradient of the original line. So say the gradient of the tangent was 3, the gradient of the normal is negative 1 over 3. They can give you quite a long-winded question about this, so they'll ask you to find the gradient of a normal and at a certain point, but they won't ask you to find the gradient, they'll ask you to find the whole equation of the normal. So it'll mean finding the gradient of the tangent, using that to find the gradient of the normal, subbing in your value of x and y, because they'll give you the point value, into y equals mx plus c with your gradient, and then you'll find c, and then you'll have to give it in whatever form they ask for. I did one of those on the train the other day. It was a 7 marker, which is quite a lot for a core 1 paper actually. Integration is basically the opposite of differentiation. So say you've got a differentiated term or equation or whatever, if you integrate it you will find the original term. So to integrate, you raise the power by 1 and then you divide your term by the new power, and after you've integrated a whole equation or sequence or chain or whatever you want to call it, not a sequence, ignore that, you have to always put plus c. That's always worth the mark, really important, and I always forget to do it. Now I think a useful way of remembering which way round to do your power and multiplication or division is you do the one that increases it first. So for differentiation you multiply first and then you lower the power because you do the one that does the exciting thing first, and for integration you're raising the power first and then you're doing the division, because that's sadder. Obviously it's reduction, well, unless you're dividing by a half or something I suppose, but you always raise the power first for integration. We've got an example here, so 8x to the 3 minus 4x to the minus 3 plus 4x minus 5, if we're integrating it we'll raise the power first, so that'll give us 8x to the 4, and then we'll divide by the new power, so that'll be 8x to the 4 over 4, which is 2x to the 4. And if you carry on along there, you will just see how it goes, and it carries through. And if you've got something that's by itself, like minus 5, 10, 3, 2, you just add an x to the end of it, so minus 5 goes to minus 5x, 4 goes to 4x, 12 goes to 12x. And then you have to have your plus c at the end. So important. And then say they make you integrate a differentiated thing to get your original equation, then they might ask you to do it at a certain point, and you're subbing your values to find the value of c, and then you'll use that to give your equation in the form y equals mx plus c, or whatever form they ask for it in. If you don't remember your plus c and then you have to find the equation of a line, you'll get the wrong equation because it'll totally mess up your results. And we have reached the end. I know we rushed integration quite a bit, but that's because there's literally hardly anything to it. Just as long as you can integrate and you understand all the lines and everything, that's all you really need to know to be able to get your integration marks. And that brings us to the end of the Core 1 video. Hopefully there's everything you need in here to be able to pass a Core 1 paper and get a good mark. I mean, if there's anything you want to know or anything you want to go over in more detail, then just comment or email me or something like that. And have a lovely day, and don't let the revision bog you down too much. I think just a quick note about revision actually, the best revision for Core 1 and any maths really is past papers, I think. I mean, some people disagree and they say no point doing past papers, but I've seen results that I've done go from D's to A's over a few days just by doing past papers, because that gives you the best practice, all the variety of the questions and everything. So I think just do as many past papers as you can, and essentially Core 1 you should be able to get down to about half an hour, 3/4 of an hour to be able to do it, meaning you get quite a long time to check it. And that's most people. I've spoken to a lot of people, and that's the common theme. You can do Core 1 very quickly once you've done a lot of practice. Anyway, I'll shut up now. Bye!